Alrighty, good morning or good afternoon, ladies and gentlemen. Today I'm going to cover a quick little mini lesson from the last two questions of our interest assignment. So these questions are what I would call compound interest with multi-step questions. Everything on that backside deals with that compound interest formula, that A is equal to P times 1 plus R over N to the N times T. So there's going to be a bunch of things to deal with. The issue with both of the questions that you have, and I have similar examples here, is that money is being added in or paid off, which is going to change the amount of interest. So we have to think about each part separately. So I have two examples here that are basically rewordings with some of the numbers changed of the last two questions. So how much was Roger's loan if he pays it back in 1 year and must pay back $800 in 6 months and then $2,000 at the end of the year? So, and the loan was 4% interest compounded semi-annually. So how I can split this up is I can think of the first 6 months and the last 6 months. Now, we're going to simplify this question a bit and just deal with the fact of how much he paid off and realizing that the interest is going to be added on, so he has to pay that off as well. So for each of these, I'm going to have A1, P1, R, N, and then time 1, and then A2, P2, R, N, and then T2. So I'm splitting this up into two sections, and then I'm going to add the values together. So the way I can think about this is at the end of the year, he pays back a total of the $800 and the $2,000. So the amount that the person pays is going to be our A1 and A2. The reason being is in total, he pays $2,800. That is interest, that's part of his loan. So it's not the principal, it's not how much he borrowed, but rather it's how much he paid back. So in this case, it's asking how much was the loan. So I need to figure out each one individually. However, there's a couple things that can help us. First up, R and N are the same. So R in this case, if it's 4%, is going to become 0.04. So I don't even have to calculate this one. It's going to be the same. It's compounded semi-annually. So this means N is equal to 2. So it's happening twice a year. And then the time for each of these, it happens in 1 year in total. But again, I'm looking at the first 6 months and the last 6 months. So each of these is 1/2 of a year. So to set this up in my equation, my first one is 800 is equal to P1, 1 plus 0.04 over 2, and then 2 times 0.5. And you'll notice that this one is very similar. The right-hand side is identical with the exception of I'm replacing P2, but this is 1 plus 0.04 over 2 times 0.5. So from here, I can simplify down this bracket here as well as the exponents. So 2 times 1/2 is going to be 1. So I'm going to have 800 is equal to P1. And let me just deal with this one first. And then this will be 1.02 to the power 1. And 1.02 to the power 1 is actually pretty easy. It's just 1.02. So I can simplify this down to 800 is equal to P1 times 1.02. Or I'll put brackets around just so we know it's multiplying. I don't have to do any work over here because this number and these numbers are the same. So I can make this 2,000 is equal to P2 times 1.02. So a good thing about this question is that both the first and second half look identical, but I'm just going to be solving using the different numbers on the left-hand side. So 800 is equal to 1.02 times what we put in. So I'm going to divide both sides by 1.02 to cancel out and do the opposite step. So then I'm going to end up with P1 is equal to 800 over 1.02. And you'll notice that the value should go down. So he borrowed $784.31. So the extra like $15 or $16 that he paid was purely interest. So this is what he borrowed from that first 6 months. And then from here, same thing, P2 is equal to 2,000 divided by 1.02. And then this is going to give me a P2 value of $1,960.78. Now, the total amount that he borrowed, I'll call it P, is equal to P1 plus P2. The amount that he borrowed from the first half and the second half, if I add them together, will be the amount that he borrowed in total. So this is equal to 784.31 plus 1,960.78. And this equals a grand total of $2,745.09. And the reason why I have to split it up this way is because the interest is going to change as I pay it off. Because compound interest deals with what is currently being owed or what is currently in the account, the more I add or the more I take away, it's going to raise or lower my interest rate accordingly. It'll make more sense in the second example. So Jovana started an RRSP, which stands for a Reserve Retirement Savings Plan. It's basically a way of putting away money, or sorry, a registered retirement savings plan. So basically you put money away and it holds it in an account for a set period of time until you retire, and then you have access to it. So then the interest builds up and you basically have access to a large nest egg that you can live off of. So Jovana started an RRSP on January 1st, 2015 with a deposit of $4,500. She added $500 on January 1st, 2015. Whoops, I made a typo here. This should be 2016, 2017, and then 2018. That's my bad. So basically, every year she deposits a little bit more. So she starts by depositing $4,500. She adds $500 the next year, $3,000 the next year, and they want to know what the accumulated value of her account. So this is RA on January 1st, 2018. If the interest is 2%, so R is equal to 0.02 and is compounded monthly. So it happens 12 times in a year, so my N is equal to 12. So the problem with this, I can't just add all of the values in at the beginning, because then that means that she's going to be earning interest on money that she hasn't put into the account yet. Like if I just added 4,500, 500, and 3,000 to get to 8,000, and then did it for 3 years. The issue with that is that she only put in 4,500 at the beginning of the year or the first year, and then added those values later, so they don't have as much time to gain interest. So the way I'm going to set this up is year 1, so then I have 2015, I have 2016, and then 2017. So for here, I have A1 is equal to, I don't know, I'm trying to figure it out. P1 is equal to, well, she starts with a deposit of 4,500. R is equal to 0.02. N is equal to 12. And then T, I'm only going to go 1 year, because I'm going to go from 2015 to 2016. So it's going to be 1 year. So I'm going to use my A is equal to P times 1 plus R over N to the NT. And I'm going to solve for A1. So I have 4,500. 1 plus 0.02 over 12. and then it'll be 12 multiplied by 1. So a couple things that can make our lives a little bit easier for us is I'm going to solve for what's in the brackets because I'm going to use it a number of times. So first up, this simplifies to just 12, and then I'm going to get 1.0016. So I'm going to remember this rather than have to calculate it each time, because for each year the interest rate is the same, and for each year the number of times it compounds the same. So I'm always going to be using the same numbers. So I'm just going to use that as my stand-in, and then I'm going to calculate. So I'm going to get A1 is equal to $4,590.83. So at the end of 2015. So at the end of 1 year, she's going to have an extra $90.83. Well, in here, in 2016, she adds $500. Now, normally, this we could make our new principal and keep going. The whole idea of compound interest is I should be able to just calculate the total amount. But instead, I'm going to think of a principal 2 is equal to the previous amount. So I'll write previous amount plus deposit. So in this case, P2 is equal to $4,590.83, and I'm going to add $500 to it because that's how much she put in at the beginning of the year. So then this new value is $5,090.83. So then A1 is equal to, A2, because now I'm solving for my second year, is $5,090.83 times, this is where that 1.0016 and the 12 come in handy, because it will not have changed during the second year. And again, I'm counting it only for 1 year because something happens in 2017, so I want to just do this 1 year at a time. And then this is going to give me a grand total of $5,193.59. So they've made a little bit more interest. This time they've made a little bit under 100, so about $97 rather than 90. And part of that is from that extra $90 they put in, but also from that extra 500. We've increased the principal by even more. So then lastly, for this one, we get to 2017. There is a new principal, which again is this previous amount plus deposit. And in this case, Jovina adds $3,000. So a large chunk of money. So in this case, it would be $5,193.59 plus $3,000. So this is going to give me a P3 of $8,193.59. So again, I'm going to calculate the final total is equal to $8,193.59 times, and I'm going to highlight it, 1.0016 to the power 12. And then solving for this, I get a final value of $8,358.97. One of the differences that you'll notice, so in the previous example, I added together my values because they were the principal. If I'm finding the amount, it's the amount at the very end. So this one, when I'm calculating amounts, I'm not wanting to add my A1, my A2, and my A3 because this, my A3, already includes A1 and A2. So keep in mind, interest is a very tricky problem. So some of the things I did to help me, I split up into 3 basically mini problems where I use my answer from the first one and added the next value or added the next deposit to it, and then did the problem again. And then once I found the problem or the solution to that this year, I carried this amount forward, and then I added the amount, and I did the problem again. Shortcuts with these is that oftentimes if the interest rate does not change, you can keep using those values in the brackets, because unless your time is changing, your exponent is going to be the same, and likely your rate will not change year to year or the amount of times it compounds. So you can use what's in the bracket, solve for it once rather than 3 times and risk getting it wrong once. And then just keep working through. So this is a very sort of methodic problem. So break up any problem that you see like this into smaller chunks, especially if you see one that's a number of years where things are changing year to year. Try to split it up. And this one, the hints is that it talks about January 1st, 2015, and then January 1st, 2016, 2017, and then 2018. So it's referring to specific days of the year rather than just saying she deposited this much money for 5 years. So keep that in mind. Hopefully this helps explain and clarify those last 2 questions. I'll post this up right away, and take care, stay safe, have a good one. Bye.